And here we go. As we step into that other universe of complex numbers. Let me take a little drink of coffee. Ah. Okay, now. I'm looking at the clock too. I don't want to start too early, but it's 7:29, almost 7:30, so I think we are safe. I'm going to draw a little star here. More of an asterisk. This is where we live, right here. We live in the real number system. That's where all of the numbers that we are familiar with live. So for instance, the integers are just whole numbers with, they can be positive or negative or zero, and that right here, that is the symbol, a Z with 2 bars. You don't have to know that, I'm just showing you. And then there are the rationals. The rationals are numbers that are fractions or that can be made into fractions. All of the integers can be made into fractions, so they're part of the rationals. And a Q with 2 bars is the symbol for the rationals. And the irrationals are much more problematic. And the symbol for the irrationals is, no, it's an I with 2 bars. Irrational starts with an I. Pi is an irrational number. It has a decimal expansion that goes on forever. E, you don't know about E yet. It's a number that's about 2.7, but it has a decimal expansion that goes on forever. The square root of 7 or negative the square root of 7 or the 5th root of 2. All of those are irrational numbers, and they are on the x-axis and the y-axis. They're real, they're in the real number system, but they're kind of more of a problem that we don't deal with that often. And of course, talking about square roots, you know that you cannot, in the real number system, take the square root of a negative number. You'll get an error message. The error message says non-real number, and that's because square roots of negative numbers live elsewhere. They live out here in the complex number system, right there. And the complex number system is so big that it completely engulfs the real number system, so that the real number system is actually a part of the complex number system. Okay, but this is much bigger. It's kind of like if that were our solar system, this is the larger universe. And out here, the square root of -1 really exists, and it's used a lot by electrical engineers. The symbol used for the square root of -1 is a lowercase I. Okay? And complex numbers have 2 parts. One complex number has 2 parts. And an example would be 3 plus 2i. The formula is a plus bi. A is the first part, it's called the real part, and it's a number like 3. And bi is called the imaginary part, and that's not because it's imaginary, but because back in history, when a lot of mathematicians thought that these numbers didn't exist because they weren't in the real number system, they were called imaginary. It was kind of a put down. Okay, and then Gauss. Gauss, who created Gaussian elimination, okay, that Gauss. Gauss proved that these guys really exist, and that these really exist, and he made electrical energy, the use of electrical energy, possible. He created the mathematics for it before scientists started working on building the grid. Okay, so we're going to be reviewing complex numbers first. We're going to be reviewing the part of complex numbers that we have to deal with when we're solving quadratic equations. So, the square root of -19. Here's what you do with that. Now notice you have to read the instructions. Simplify your answer, that means break it down, and type your answer in a+bi form. That's the formula. So you're going to have a real part and an imaginary part, and I'll show you how to do that. Okay, so the square root of -19, of course that doesn't exist in the real number system, so we have to go out to the complex number system. Rewrite it like this. Which is true. -19 equals -1 times +19. Well, that's the square root of -1 times the square root of 19. And the square root of -1 is I. So a common way of writing it that's really not the correct form is I times the square root of 19. However, the instructions say to write this in the form a+bi. So I have to do that. All right, a+bi. The square root of 19 times I is going to be written like this. But make sure your I is on the outside of the square root sign. Well, what do I put here? There is no real part, right? The only thing is I times the square root of 19. So you're going to write that as the square root of 19 times I and put a 0 here. So 0 plus the square root of 19 times I is your answer. That's how you would write it.
Ms. Rademacher?
Yes.
Sorry, if we put the I under the, or right under the, what is that called?
Radical.
Yes, is that incorrect?
Oh yeah, super incorrect. Good question. Good, any more questions? Okay, now I admit this stuff is pretty weird. Now here, you're going to see this is a little bit different. The square root of -8. You know that 8 has a square root inside it. I'll show you. This is -1 times 4 times 2, where 4 is a perfect square. So when I write this out, I have to write it like this. All right, the square root of -1 is I. The square root of 4 is 2. And then the square root of 2 won't break down. It's an irrational number. Then the instructions say we have to write it like this. So we'll write this way. And there is no number that goes out here. So we'll put a 0. And that would be your answer. If these were not the instructions right here, if it just, and you'll see this sometimes, like this one. Here, let's just do this. All this says is express in terms of I. You'll see that writing the answer to this is a little bit easier. Okay. Now this negative is on the outside of the square root sign. You're not going to say negative times negative is positive, because this, well, any number outside the radical cannot communicate with a number inside the radical. So this stays separate. This is going to be negative the square root of -1 times 31, which is going to be negative the square root of -1 times the square root of 31, which is going to be negative I times the square root of 31. And if you're told that you can just express your answer in terms of I, you don't need to worry about a plus bi, then this is a perfectly good answer. If you had to write it in terms of a plus bi, this is what you would have. Yeah, yep, nope, nope. Like that, because of the negative sign in front. But it didn't say that, so you don't have to write it like that, but this is just for your information. Now here we have another one of those negative signs in front. This is going to be negative times the square root of -1 times 16, which is negative times the square root of -1 times the square root of 16. Well, 16 is a perfect square. So this is going to be negative I times 4, which would commonly be written as negative 4i. And again, you don't have to write it in terms of a plus bi unless the letters, the blue letters underneath the answer box tell you to do that. Now these are very tricky, okay? Watch what I do. The answer is not what you'd expect because you're in a different number system. Okay. The square root of -1 times 4 times the square root of -1 times 25 equals the square root of -1 times the square root of 4 times the square root of -1 times the square root of 25. So we're going to have I times 2 times I times 5, which is 10I squared. Now, there is something you must memorize, because you're going to run into it all the time, and that is that I squared equals -1. All right, you've got to memorize that. I'll show you why in a minute, but for now, that means you have 10 times -1, which is -10. The answer to this is -10. Now here's why I squared equals -1. We know that I equals the square root of -1. So I squared equals the square root of -1 squared. Well, in the complex number system, which works a little differently sometimes than the real number system, this square and that radical cancel each other out because they're inverse operations, leaving you with -1. Now this is in the complex number system. In the real number system, admittedly, this would work a different way. I squared would equal, or let's change the letter. Let's change the letter. Suppose, let's call it Z squared. Suppose Z squared equals the square root of -1 squared in the real number system. Well, of course, that doesn't exist, but let's put this in real, R-E-A-L. What would happen in the real number system, our number system, is that this 2 would come down underneath the radical here, which it can always do, and it would square that -1, so it would become +1. So that would be the square root of +1, which would be 1. But we're not in Kansas anymore, to quote the Wizard of Oz. We're in the complex number system, and in the complex number system, I squared is going to equal the square root of -1 squared, and that are going to cancel each other out, leaving you with -1. Again, anytime you see a negative number underneath the square root, it means you're not in Kansas anymore. You're not in the real number system anymore. You're in the complex number system. I like to say you've been drop kicked into the complex number system. And it's just the way it is. So this is like those. Let's do this. we're going to have the square root of -1 times 9 times the square root of -1 times 36. And this is going to equal the square root of -1 times the square root of 9 times the square root of -1 times the square root of 36. So we're going to have I times 3 times I times 3. Nope, times 6. There now. Whew. So we're going to have I squared times 18. Right, 3 times 6, yes, 18. Now, I squared is -1, so we'll have -1 times 18, which is -18. Okay? When I was a student, I found these very tricky. I even missed a problem like this on the test once. I was so mad at myself. So I never forgot it. Sometimes missing a problem can be really good for you. Okay, now we're going to multiply. We're going to multiply two complex numbers. These are individual complex numbers. This is a complex number, 4 plus 3i, and this is a complex number, 3 plus 7i. Remembering that complex numbers have two parts, a real part and an imaginary part. But I'm going to multiply them just like I would any two binomials. You can FOIL or you can distribute. So I'm going to take the 4 and multiply it by 3, and the 4 and multiply it by 7i, and the 3i and multiply it by 3, and the 3i and multiply by 7i. And that will give us 4 times 3 is 12. 4 times 7i is 28i. And 3i times 3. 3i times 3 is 9i. And 3i times 7i, 3 times 7 is 21, I times I is I squared. So we're going to have 12 plus 37i plus 21 times -1. So that'll be 12 minus 21 plus 37i. And so our answer is going to be -9 plus 37i. And that's how the I squared works. It's pretty cool that it just becomes a number. Here's another one. do it the same way. We're going to have negative 5 times 2, negative 5 times negative 7i, 9i times 2, 9i times negative 7i. So we have some negatives in there. That makes it, that always makes it a little bit more interesting. Oops, I didn't use blue. I always use blue, but I'm not going to do it now. Negative 5 times 2 is negative 10. Negative 5 times negative 7i is positive 35i. And positive 9i times positive 2 is plus 18i. And positive 9i times negative 7i is going to be minus 63i squared. Let me make sure that's right. 9 times 2 is 18. 5 times 7 is 35. And 5 times 2 is 10. Okay, so we are going to have negative 10 plus 5 plus 8 is 13. Carry the 1. 1 plus 3 is 4, plus 1 is 5. Now minus 63 times negative 1. So that will give me negative 10 plus 63 plus 53i. Now negative 10 plus 63 is 53. So the real part is going to be 53, and the imaginary part is going to be 53i. And the answer is in a+bi form. Now, if you know your conjugates, you recognize this as your friend. Want to write it bigger here. Notice that the first numbers in each set of parentheses are exactly alike. And the second numbers in each set of parentheses are alike. And you have opposite signs in the middle. Now this should start your brain clicking. A squared minus b squared equals a plus b times a minus b. That's the formula for the difference of two squares. It's the answer you get is exactly what these are. These are called conjugates. You have conjugates when the first terms are exactly the same and the second terms are exactly the same, but Go to a different color. Yeah, just go to black. The signs in the middle are opposite. These are called conjugates. Which is Latin for plays together. So notice the wonderful, wonderful thing that happens when you multiply conjugate binomials, which are the only kind of conjugates I think there are. All right, we're going to multiply. Okay, let's start over. 4 plus 2i times 4 minus 2i. 4 times 4, 4 times minus 2i, plus 2i times 4, and plus 2i times minus 2i. That will give us 4 times 4 is 16, and 4 times negative 2i is negative 8i, or minus 8i. And positive 2i times positive 4 is positive 8i. And positive 2i times negative 2i is negative or minus 4i squared. Now notice that when you subtract 8i and you add 8i, all that is 8i minus 8i. That's 0i, which is 0. So this is 0. And then this will be negative 4 times negative 1. So we're going to have 16 plus 4, which is 20. There are no i's here. You get your i's from the two middle terms. And when one is positive and one is negative, they zero out. They add up to 0. So they're gone. All of your I terms are, both of your I terms are gone. And all you're left with is a nice number. So if you're prepared for this, and if you know for sure you're dealing with conjugates, what you get as your answer is the first term squared minus the second term squared. Now here we had a plus. What do you mean by that? Well, negative 4. Oh, right. We got 16 minus 4i squared, which gave us 16 plus 4. If we had done it this way, we would have had 4 plus 2i times 4 minus 2i. These are conjugates, so we can do the following. 4 squared minus the second term squared. Okay, this is going to be 16 minus 4 times I squared. Well, I wouldn't do that. Instead, I would have written it, you would normally write it like this. And then you would say to yourself, self, I squared is -1. So this is 16 plus 4. So this is 20, which takes away some of the work. Not a lot of it, I admit. Probably it only saves you 2 steps at most. But some of them you can actually do in your head. Okay, that's it for complex numbers. Get you ready for your homework. Any question about these before we go on to solving quadratic equations by factoring? Only we're going to go a little farther than you would have gone at first in intermediate algebra. Okay, all right. So we have to use the principle of zeros here. Here's an equation. You've got stuff on the left equals stuff on the right. Stuff equals stuff. That makes it an equation. And the highest power is 2, so this is a quadratic equation. Okay. Now, one of the most important things we have to do when we solve what are called higher order equations, that is, the highest power is above 1. We have to use the principle of zeros. And here's what that says. It says that when you're solving, say, a quadratic equation, ax squared plus bx equals -c, you've got to bring that c over and set this equal to 0. So you add c to both sides because there's a minus in front of it. And you'll have ax squared plus bx plus c equals 0. This is the formula for a quadratic equation. Okay, so I'm going to subtract 10w, 10w from both sides of the equation. W squared minus 10w plus 25 equals 0. Now I need to factor. There's a 1 in front of w squared, which means the leading coefficient is 1, which means I can take the easier path to factoring. But don't forget your equals 0, it's very important. Split w squared apart. And now factor 25 into two numbers that add up to -10. Well, what do I know? I know 25 equals 5 times 5, and that 5 plus 5 equals +10. But I know that any positive number also equals a negative number times a negative number. So 25 will also equal -5 times -5. And -5 plus -5 equals -10. So bingo, -5 and -5 are my two numbers. So I put a -5 here and a -5 here. Okay, now we have factored this. Now we have to move on to solving. Here's how you solve, just to help your memory kick in. You set each of these binomial factors equal to 0 and solve the resulting small little equation. And these are the same, right? So you're going to get the same answer. W minus 5 equals 0, and W minus 5 equals 0. So I'm going to add 5 to both sides of the equation, little equation. -5 plus 5 is 0, and so W equals +5. And I'll have the same thing over here. W equals +5. The solution to my equation is W equals 5. And so in my math lab, you're going to have W equals, and then the answer box. And you're going to type 5 just once, because each of these numbers is 5. So there's no need. All you're doing in the answer box is listing answers. But just for the future, I want you to know that the fact that 5 occurs twice means the following. We call this multiplicity. Multiplicity 2. 5 is a solution to the equation, and it has multiplicity 2 because it occurs twice. That's coming in the future. Right now, it's enough to get the answer 5 and write it once, not twice. Here we're going to use the zero principle again. -36 minus 36. T squared plus 5t minus 36 equals 0. Leading coefficient is 1. I split my t squared apart. And I should, so that doesn't look like an H, should probably make that into a European one, which I'm terrible at. Okay, now I have to factor -36 into two numbers that add up to +5. So here's what I know. I know that 36 equals 4 times 9. I already know that. And I know that 9 minus 4 equals 5. And -36, well, 36 equals 9 times 4. Okay, and 9 minus 4 equals 5? Well, kind of, because this is really negative 36. And what that means is that one of these numbers is going to be negative. So I can have negative 9 times positive 4 and positive 9 times negative 4. And look at this, positive 9 plus negative 4 equals positive 5. So those are the two numbers I want. So I'm going to say, what am I going to say? I'm going to say, whoa, is what I'm going to say. That's not a squared, that's a t. Okay. T squared split apart into t and t, because t times t is t squared. Now I'll have plus 9 and minus 4. Now I have factored my polynomial, my quadratic trinomial. So now since it's an equation, I proceed to the part about solving equations. And the way I do that is I take each factor and I set it equal to 0. So over here, I subtract 9 from both sides. So I get t equals negative 9. And over here, I add 4 to both sides. So I'll have t equals 4. And those are my solutions. So in the answer box in my math lab, I would write negative 9, comma, positive 4. Or the other way around, order doesn't matter. What you're doing is you're listing your solutions. Most of the time for a quadratic equation, you're going to have 2 answers. Most of the time. Sometimes you have one answer that occurs twice. But here you've got 2 solutions to the equation. Feel free to just pop right on up. Okay. All right. Now notice you're going to have a binomial and not a trinomial to solve. Let me make it bigger. Okay. So zero principle says we subtract. Subtract 4s from both sides of the equation. And what that will give us is 28s squared minus 4s equals 0. Okay. Now, look at this. I'm going to get to factor by GCF. The first term contains a 4 times a 7 times an S times an S minus 4 times s, and since this term also contains a 4s, I'll put a times 1 here. I could always put a times 1 if I wanted to. Okay, well 4 is the GCF, and s, there's a 4 and an s in both terms. So 4s is going to be my GCF. My leftovers are 7s in the first term and 1 in the second term, and that equals 0. Now I've factored it. I have factored my quadratic equation. Now I set each factor equal to 0. For s equals 0 and 7s minus 1 equals 0. Divide by 4, divide by 4. 0 divided by 4 is just 0. You can have a 0 solution. Now over here, this is a little more involved. I have to add 1 to both sides of this equation. Negative 1 plus 1 is 0, so that leaves me 7s equals 1. And then to solve for s, I divide by 7 and divide by 7. So s equals 1/7. And so in my math lab, you'll have s equals 0 and 1/7. The s is already written for you. S equals, and then the answer box, and then your answers, or the solutions to the equation. Okay, I haven't heard anything from anyone. Are you all remembering this okay? I hope you are. Do you have any questions about anything I've done so far?
No.
No, thank you.
Okay. Then we shall move on. All right, here is a quadratic binomial. And each of these terms contains a 3. 21 is 3 times 7. So we'll pull out the 3 GCF. And we'll have x squared plus 7. Because 3 was our GCF, and there it is right there. Now we have 2 factors, and what we customarily do is set each factor equal and solve for the letter, which in this example is x. But notice that 3 is just a number. It doesn't have an x that can equal 0. So what do? I do something I can only do when I have an equation, so that I can do it to both sides of the equation. That won't change what I'm working with. It won't change the equality of what I'm working with. I'm going to divide both sides by 3 because 3 is just a number. If there were an x there, I could not divide by 3. Maybe I could divide by 3, but definitely not by the x. But there is no x. So I can just joyously divide both sides by 3 so that I get x squared plus 7 equals 0. Okay, I have to solve for x. Notice that x squared plus 7 is not factorable by any method we've learned so far. Now you get to learn a new method, well, not new, because you would have studied this in intermediate algebra, but maybe new this semester, method for solving quadratic equations, and that's called the square root method. So here we go. Let's move this over here. X squared plus 7 equals 0. The first thing I do, notice there's not just an x term there, a linear term. There's only the quadratic term and the constant term. I'm going to subtract both sides. That is, I'm going to subtract 7 from both sides of the equation. That will give me x squared equals negative 7. Nobody cares what x squared equals. So I'm going to take the square root of both sides in order to get x. So the square root of x squared equals the square root of negative 7, and in front of this I put a plus and minus, and I'll show you why when I'm done. The square root of x squared is x equals plus or minus the square root of negative 1 times positive 7, which is plus or minus the square root of negative 1 times the square root of positive 7. So x is going to equal plus or minus I times the square root of 7. And how you write this in the answer box, then I'll show you why with an example. Negative I times the square root of 7, comma, positive I times the square root of 7, unless the instructions say, and they don't, unless the instructions say to only use a+bi form. If they did, this is how you would write it. This will take more room. So I'm going to leave that open and close it later. 0 minus I times the square root of 7, comma 0 plus I times the square root of 7 no, because I wouldn't put the I first, would I? Let's do that again. 0 minus the square root of 7i, make sure it's outside the radical, 0 plus the square root of 7i. There you go. Now, why do you have to put that plus or minus? I'll show you. Suppose, just suppose. Now, this is an example. Suppose you had x squared equals 9, which conveniently is a perfect square. I'm going to pull that over to the other side by subtracting 9 from both sides of the equation. Bear with me. I'll have x squared minus 9 equals 0. Now, I can factor this by the difference of two squares. So I'll have x plus 3 times x minus 3 equals 0. And I set each factor equal to 0. X plus 3 equals 0. And x minus 3 equals 0. Let me clean that up. Now, when I solve this, I subtract 3 from both sides. So I get x equals negative 3. And over here, I add 3 to both sides. So I'll get x equals positive 3. So I have two answers. I have two solutions to this little equation. And they are negative 3 and positive 3, which can also be written plus minus 3. So writing the plus minus here just compensates for the fact that that's what you would have if you worked this all out like that. You would have two answers. One positive, one negative. Okay. So just remember to do it. If that wasn't understandable, then just remember to do it. When you use the square root method, and sometimes you just have to. Now, finally, we're going to use U substitution. Okay, 4 is 2 times 2, so that means I use U substitution. U equals x squared, and U squared equals x squared squared, which is x to the 4th. So I will rewrite this as U squared minus 10U plus 9 equals 0. And the leading coefficient is 1. So, equals 0. I'll put a U here and a U here. Okay, now I factor positive 10 into two numbers that positive 9 into two numbers that will add up to negative 10, And that would be -1 times -9, because -1 times -9 is +9, and -1 plus -9 equals -10, which is the middle number. So -1 minus 9. Now, u minus 1 equals 0, and u minus 9 equals 0. I add 1 to both sides, so I get u equals 1. And I add 9 to both sides, and I get u equals +9. Really? Yeah, all right. Well, that's great. I feel like I'm done, but I'm not, because look what u equals. U equals x squared. So I am going to have x squared equals 1. Let's continue on down. And x squared equals 9. Now I can pull this over and factor by the difference of two squares, or I can use the square root method. Let's use the square root method to help you learn how to use this. I take the square root of x squared equals plus or minus the square root of +1. And over here, I'll take the square root of x squared equals plus or minus the square root of 9. Really? I am disappointed. Yeah, all right. I thought it would be harder. Doggone it. All right. So the square root of x squared is x equals plus or minus the square root of 1 is 1. The square root of x squared is x equals plus or minus the square root of 9 is 3. So when it gets over to your answer box, you're going to have -1, +1, -3, +3. And you've got 4 answers. Why do you have 4 answers? And the answer to that is that your highest power is 4. Linear equations here's a linear equation. 3x plus 2, 3x plus 3, let's make that. 3x plus 3 equals 6. Notice the highest power is 1. You're only going to have one answer. Subtract 3 from both sides, and you'll have 3x equals 3. Divide by 3, divide by 3. You'll have x equals 1. A quadratic equation has highest power 2. Let's go back and find one. There. T squared plus 5t minus 36. This was plus 9 minus 4. I subtract 9 from both sides. Oh, wait a minute. I subtract 9 from both sides, I get t equals negative 9, and I add 4 to both sides, I get t equals positive 4. Anyway, there are two solutions. Most of the time there are 2. And that 2 matches that 2. So here we have highest power 4, and we've got 4 solutions to the equation. That's something else you're going to be learning in college algebra. And that is it. Perfect timing. Your notes and videos are already up. I do almost all the problems, but since I made a video here anyway and have notes anyway, I'll come down underneath and I will also load your video and your notes. Okay, and tomorrow, what do? Tomorrow we move on to the Wednesday, we move on to the quadratic formula and several word problems, I think. For sure, the quadratic formula. So I will see you then. And if you have questions, please hang around. Be careful. Gosh, there's so much snow outside.